again, thank you very much, Massimo, for being here. Massimo, beyond being a very good friend of mine, is a full professor at Messina University, and he is working on cloud edge topics, and in particular the osmotic computing paradigm that he kindly accepted to present to us. I really hope that this paradigm and the work that Massimo is doing and has done so far could be very helpful and for our project. And I really envision some collaboration with him and his group, if possible, starting very good work and collaboration all together. So thank you again, Massimo, for participating to this series of webinar. And I'm really excited in having you here and listen to your presentation. So please, the stage is yours, and thank you again.
Thank you, Patrizio. It is really a pleasure to be here. Let me say thank you to you and to all the people that belong to Accordion. Repeat, it's a really important thing to try to collaborate each other, to put on the table something that we can use for the future. This is the main aim of this my talk. Essentially, we started several years ago introducing new paradigm because we understood that we need to simplify several things. I wanted to share with you all this. As you said, I'm full professor in Messina in computer science, but also delegate on ICT and the head of computer science school. There are a lot of busy things to do, but you know, it's something that you like to do and you do by the passion. As I said before, we're trying to foresee the future, essentially, for having new opportunities, collaborations, projects. It's an our moment. ICT is on top of the wave, and we have to push it as much as possible. You cannot imagine, even in my university, I talk every day with the doctors because we have a polyclinical in health, but we have also people in pharmacologists, in any area, even economics. We are looking for how to apply ICT technology to speed up their needs and their capabilities. So we are looking for the future. And of course, the future is a time of a cloud continuum. Something that we know very well is some paradigm try to gather cloud edge, but we put in place fog. I put everything in the picture, even AI. There is a big hype in AI. We present a few slides on there. And repeat, we're looking how to move forward and why we introduced this concept of osmotic computing. And one of the main aspects I want to share with you is about namespace, because we strongly believe that the step over for osmotic is understanding where resources are and how we try to apply it in osmotic computing, something quite new we are working in these days. And but some other partners, because we have the initial stake of osmotic computing platform that we can all of you can leverage. Repeat, I like to give a look what's happening in the last 10 years. And as Patrizio knows, we started Messina for a long time ago in the area of cloud. And I like when I go abroad, worldwide, to present the hype curve of Gartner that allow you to know how the human perspective, the human wish can match. It's a graphical representation. I like it. It's something that we have in our human activities. You see something new, and you have this peak of expectation. You see how it's not true. Some disillusionment, and then you go toward the plateau. And it's okay, something's really valid, you continue to use it. It's something that happened a long time ago, but I want to focus specifically. You see here, cloud is a little bit up above the peak. It's something that we have the real peak in 2009. So cloud is really fully consolidated. It was funny that nowadays we see that people continue to think how to use cloud and to use cloud and what are their, let's say, implication in using it. So essentially cloud for is not into the domain, because people that are working a lot on cloud knows already there are some kind of utilities like electricity, like water, that allow you to plug the computation. It's essentially the starting point, and you can benefit of it. So some brilliant idea from Amazon that started with some collaboration with VMware roughly 20 years ago, a little bit less. And the idea is to have different resource pools and you can use them on demand when you need it. Essentially, repeat, like electricity, you plug, like water, you open the tap, like gas, and so on and so forth. You don't know what are resources, essentially. That's why the cloud, and much more, however, many people are already using it in different perspectives. In the storage example, it's well-known Dropbox, Google Drive, the others where you have your pen drive. You can put, let's say, infinite data storage and to use it. This concept of infinite units, I mean, internet connection, and you feel like infinite resource in computation and storage. As I said before, cloud was something that was really disruptive for all of us, essentially for Europeans. I remember when I moved from Brussels to Sicily back, it was by Lufthansa. There was a newspaper looking at the time about the issue with GDPR problem. Was before, of course, they mentioned the issue with the less GAFAs, Google, Apple, Facebook, and Amazon, that have, let's say, the majority in tricking our data. And the European Commission was quite scared at that time. So it was really few years before GDPR, as you can see here. Why I put in the picture GDPR? Because the privacy is something that we have to deal with nowadays. Every 2 days, 3 days, there is some issue with Facebook, with Google, with some other company that many people try to get your data. This is not really good. But I want to remark something important on the cloud. The cloud it was really disruptive cloud. Why this? Because we introduced the concept I pay as you go. In some things you click. There is a well-known paradigm where you look for operating cost. You don't go for buying stuff. You don't buy. You use what you need, essentially on demand, pay-per-use, click and go. Repeat, something that we know very well, even for some facility, but even now. Even sharing Airbnb, there was some new paradigm. Just to give an example, but you can see there, even Just Eat in the time of COVID, and of course Uber, not in this moment, but before the COVID, it was really disruptive. Essentially, what we can see in the sign kind of the future was this kind of disruptive factors. These destructive factors, essentially, we can set up them in different areas. You see some interesting stuff like, I don't know, concurrency is important. It introduces DevOps procedure. What? Then you have this kind of rapid deployment, continuous integration, continuous development with the build, release, and run. Repeat, the cloud give an opportunity to use a lot of this new technology, and we appreciate it a lot. And then there was the way of connection that we are sharing by the COVID. This presentation thanks to fiber optics that I have at home, but each of you has many possibilities to gain the connection. You see how many bits you can have during the years. Repeat, you see this kind of power 10 factors every few years, every 5 years, and it was really amazing, if you can imagine. Okay, for this reason, I like to some way to link the cloud with the fog, because it was a really great challenging behind the cloud, and all the other operators in the cloud, not only, let's say, the conventional one, try to leverage its capabilities. One of these operators are the telco operators. I say, oh, we are in the picture. Telco operators that provide you networking, that provide you connectivity, but even network equipment. There was a definition of Cisco about fog computing, and we can see it on the WIKI, just to fix the boundary, what you are discussing very well. And just to make a clearness, because we have a real clear understanding of cloud, less clear fog, even less edge. But let's look to them to understand how this continuum is important for us to manage resources, essentially. Okay, as you can see here, cloud and big data needs networking stuff. This is why this was introduced this fog with the control plane and data plane, where you have the capability to adjust the network according to your requirement, essentially. This is what you need. Okay, of course, to foresee networking useful for the edge, and when we talk about the edge, you have to think to the, I don't know, IoTs, RFID, barcode, all the devices you have close to the user, essentially. What do you need for fog? If I remove fog in the picture, let me move the slide here. Okay, very well. If you look at the capability of fog, you don't see really a great difference with the cloud, because you're talking about security. I already mentioned GDPR, try to have security and privacy. Scalability, you try to scale out of the generic resource you can have inside your data center. Should be open, autonomy, programmability is very important. You have to change the behavior on fly. Dynamically is possible. And then you can have reliability, availability, and serviceability, something really the pillars of security, and agility and hierarchy. Repeat, something that we think is quite new, but it's not new. It's something derived from cloud. Fog where we put in place the edge computing as a
Massimo, yes. Sorry. Apparently there are some issues with the network. I was wondering if it makes any sense to maybe turn off the video in order to privilege the quality of audio. Thanks.
Okay, thank you. Now is it better?
I think so. Yes, thanks. Massimo.
Okay, you're welcome. Very well. Very well. Thank you, Patrizio. So we decided that make some complex assumption. But look, you have this kind of mesh computing, you have peer-to-peer computing, autonomic, have some kind of clustering on the edge, and essentially, repeat, just to even guarantee the capability to use different type of platforms to deploy application services, and repeat, close to the end user. Okay, I like to put the focus. Why do we need edge nowadays? Even their security, for sure, quality of service, because you try to have something that the customers are asking to you. You click and you go soon because the services are close to you as customer. But security, we are trying to apply the concept of edge in the Osmotic Computing guarantee the privacy. All data should be maintained in the hospital, should be maintained in your house, should be maintained in a situation that leveraging the paradigm of osmotic computing, you try to export what is really essential for the domain. It can be an example domain of health. Again, the hypercycle, because it was the trend of IoT, just to a clear picture, 2014 we are talking about, and then we are going also for data management, 2015, and then we have industrial IoT that was really a tsunami, having a lot of IoTs. As I said, it did a lot of work in medical IoT, applying the osmotic computing, and because many devices, and something that I like to introduce you, because by the COVID, we're participating to many projects with hospitals that is at least telecontrol, remote control of patients. And repeat, we are trying to understand how you can balance capability between cloud and IoT. Of course, in the between you have the edge layer, you can assimilate the edge layer with networking with the fog, essentially, to have it federated, data intensive, and latency, and so on and so forth. You see there, even this domain where you're looking for this kind of a medical domain, looking for provisioning, service composability, portability, network management, security. Again, the same words, guys. So here we are looking for some advancing IoTs, but we are looking again the same words. Provisioning for this service discovery, selection, location, composability, because we have something dynamically, let's say, done. We are introducing here the concept of microservice that in Osmotic became macro elements. The portability, the abstraction is in this situation, avoiding vendor lock-in, because we are using, example, university Microsoft, but we don't know with many university if they can lock in, they cannot allow it to go out. We are using Zoom in this case, thanks to Patrizio and the project, but we can have many of that. And then we have another important issue with networking management. Networking is a nightmare. I will show you some slides that allow you to understand what are the difficulties in managing networking in an hybrid, a complex system, at least federated, in terms of other things. Naming, I like to remark the concept of naming. If you remember the table of content, I introduced something in the naming, this perspective, and then security for sure. Security, because we have to guarantee multi-tenancy, disaster recovery, a lot of data, many domains, many people trust of us. As I said, doctors, practitioners, electronic tribunals, and so on and so forth. So trust is something really important for us. In this domain, we introduced the osmotic computing, even to satisfy the context of e-health and to have this kind of hybrid public. And I want to remark soon to understand why do you need something like that? Because in my opinion, in our opinion, that we introduced osmotic, you need to have apply the simple roles to have a smooth usage of any kind of application on the cloud, on the fog, on the edge, in IoT, because we see them like a simple bet for all of them. Guarantee security and privacy on the edge, have a proximity in order to have a context awareness, quality of service, automatic management of balancing, reliability, availability, everything by itself. This is essentially the idea of osmotic. Going in the overall picture, we have also another important things to introduce in this scenario. We like the cloud, we understood that we need fog, we need edge, we need IoT, but all of them are there for us because the new petrol is data. It's quite well known on the future. Big data, data analytics, and then of course you can learn by the data by machine learning. Look to the data. Data massively digitally in the year 2000, 20 years ago, not before, because it was before we were some kind of analogic storage in terms of videotape, on music, and so on and so forth. Something that, for example, my daughter, 14 years old, does not know what I'm talking about with the device. Even DVD for every something really strange because they click on YouTube and they go how they prefer. But we are here in the domain of big data. And then the last remark I want to share with all of you is no monolithic anymore because the cloud pushed us to virtualize the resource. We're very happy about that. And for this reason, we try to understand how can minimize, how can reduce, how can identify something that is useful for one domain, one specific idea, and then when you need, you change it, essentially. You cannot do it when it's monolithic. It was funny. Last week, there was a well-known report in television on La Sette, Piazza Polita, trying to explain to Italian auditors of that report that the country, the nation is using for COVID monolithic application, a private television at 10 o'clock in the evening discussing about cloud. It's in our life and then it's affecting all of us. It's not possible to click on a website, you cannot have access. It's not really possible because we overcome this issue just a long time ago. You see what Zoom is doing. We're using Zoom right now. I remember very well a survey on Zoom of last year that increasing their revenues in a few months due to COVID, more of Lufthansa, the other airplane companies. Repeat, the world is changing and we have to understand that we are able, no Patrizio like us, to drive this changing. And we are good on place. Look to the microservice on the right part of the picture where you have some small elements and then it can be some way loosely coupled. You don't need to have a strongly coupled among them. User interface, and then you go from one to another one. You can set up some workflow. It's really the new way to go, microservices and workflow for the future. Even there, look into the wiki that help us to have a clear scenario. We're looking for some granularity, as I said, with a small level of coupling, losing coupling, and also with the capability of refactoring. When you need to change something, you need to change everything, but you can change a few things. Okay, what is the issue there? As I said, the issue there is networking. I think networking is trying to slow down the new revolution in what we are doing, because it's quite complex. First of all, because there were different telco operators, different proprietary hardware, different equipment, and it's quite tough. This is why we're trying to virtualize it. NFV is in this perspective that try to virtualize the function of a network to create abstraction. It was also the ETSI operator trying to make some standards that is quite hard. This is really hard. And repeat, they're using SDN, software-defined networking, as we said, data controller and a plane controller that allow you to manage the network according to your requirements. But repeat, it's not easy at all. Look into the picture. The picture are something that you remind similar to the cloud. I see many elements on the cloud, but example in this rectangle in orange that you can foresee really the computation resource, storage resource, and network hardware you can use in some way. And then you have many elements, they're really complex. And if you have to foresee that you can apply this architecture in each telco operator, it's not quite easy to manage it. And repeat, something that is quite complex on the networking area. Even 5G, 5G is some kind of element of complexity because it's about networking, and we have to understand, first of all, what are the possible use case for 5G, and because you say, okay, you need to clear really what it can be used for the 5G in the coming future. It's something that we have to think a little bit there. What is important, telco spend a lot of money and to provide this networking and just to have this kind of hand-to-hand capability where you put in place a networking. Of course, everything about softwareization, even a network. Look to the telco market slides a few months ago. That they're reducing the revenues. Netflix is increasing, Google is increasing, Apple, PayPal, and Amazon. They continue to go Salesforce because they're really cloud operators. Cloud continue to be useful for all of them, even for making profits. No good for Team, Telecom Italia, Orange, T-System. Repeat, they're not good. British Telecom, not really good in this perspective. It's quite bad. And repeat, example, there is many configuration installation of 5G in Korea, and I repeat, they are trying to consider what is really useful in using 5G. Try to have some open architecture that anybody can use. An example is OpenNFV in this perspective. Why this? Because they need to change the paradigm inside each telco. Repeat, networking is really a nightmare in this situation. I want to give you some solution. It was something that I read some time ago. I liked it because in the area of namespace that I want to share with you all. Repeat, NFV is complex. It's not easy to automate, to make some simple deployment as we do now in cloud and edge even, but not in the network. Some good idea. And repeat, all companies need to apply the concept of containerization. Is not easy because you need to spend a lot of time. For this reason, it was some brilliant idea from California. It was, if I remember well, Berkeley University, try to have the lean NFV. You cannot have this complex architecture, too complex, because cloud started with a few elements quite clear and not so complex. If you put the complexity in the network, you don't succeed, essentially. What is the main idea? Is first of all, looking for several elements. If an NFV manager, then you have a computational infrastructure, you look to the cloud in this case. you look to the computation. It's there, you use when you need, you have to make some computation, except for routing, of course, something for the control plane, and then you can use it in the case of virtualize a network, the data plane itself to use it. And then when you have these two layers, you have SDN is there, of course, because inside the device you have it. And essentially, every time you need to create some end-to-end to create it on fly, thank you to the computation, thank you to the container you can deploy. In this case, what you need essentially to know what is the service. This is why we need the ATCD and some other implementation. Key value is a big data NoSQL database. Repeat, you put it there, what you need, you link ports, you need IPs, you need names, and then you try to have magically the composition of a service even complex. This is what you need, and then you deploy on the virtual switch. It's the picture, you see the box on the bottom of this picture. Okay, you can have a key value for analytics, monitoring. You need key value at the end of the day. This is what was really appreciated, and is what allows you to have less complexity in this perspective. Repeat, networking is a nightmare. Just to give an example, what's Kubernetes, that is the manager of containers and also pods that try to make flexibility in deployment. It's a centralized system. In Osmotic, we're using different approach. We are looking for peer-to-peer, but we started from here, understanding who is working in what. You can imagine how many, there are few network model you can apply. It's a repeat, it's quite complex. You can have an open switch, you can have a flannel, you can imagine the network with Kubernetes. Look, just to give you an example, what do we need to do? We need to do this kind of a transparent migration of service that you can deploy in your cloud. For some reason, you can connect to your network, NFV, and you can interact with your edge. This is what you have to create, some kind of a tunnel, but even try to change the source of the cloud. This is essentially the idea. You can change on fly the routers, but even the protocol on the at the gateway level, in order to give to the chance to possible clusters to talk each other. Two nodes in this case, but can be generalized in clusters. This is what Kubernetes is trying to do, not easily. Okay. I gave you the story, the full story, where we are. And to say, no, too complex, too many things, just to try to simplify them, because what do you need to satisfy use cases at the end of the day? You need some provider that provide you some facility, and they need to rely on what is existing there. What is the mess of this picture? There's not any difference, no silos, guys. This is the reality, what you have seen already. You look, you try to foresee what is the cloud. The cloud is on the left part of the picture. You have a hedge. What is fog? Is inside the cloud or is inside the hedge? You cannot identify them because you're trying to making some political division of effort, but this is not true. Even some other situation can be inside the center. Somebody say, no, fog is inside the center. It's with us. No, but it is inside the hedge because it's close to the customer. You don't know where they are. What I'm saying is that at the end, it's really a mess picture where you need some big data locally to make some computation at home or in your hospital or your office. But you can have some big data management on the left part of the picture, much more close to the cloud. Repeat, you don't have any a priori boundaries. This is what we are trying to put on the table as a first example. Even Cloud Continuum is going to have these boundaries. In Osmotic, we don't have these boundaries. This is what we think. You need the fog data center, use fog data center. You need the fog in between cloud and edge, you can use fog cloud and edge. But you can also use the fog with IoT at the end of the day. Okay. Another important things. Is becoming much more powerful. Now it's time for machine learning at the edge, multiple core, a lot of capability. Repeat, we're not a small device anymore. Yeah, it's a simple example where I give you an idea that this device, example on the edge, are based on processor like MPU, but even the controller are increasing the stage, they're increasing the capabilities. Even today, I can show in the next slide that the Raspberry are looking even for me MCU. So you have to fulfill all the requirements. Your end, you have a smartphone, can be Android, can be iPhone. You can have this kind of multiple core architecture. I want to remark something really important in this moment. I remember last year when Tim Cook from Apple presented a new architecture for making computation. The architecture using is ARM architecture that we know very well is for embedded system. With my laptop in this moment that it is Intel based, I have to be honest, I'm suffering a lot because it's not stable, it's consuming a lot of power. If I touch my laptop now in this moment, it's really hot. What does it mean that? Maybe Intel make some issue in the last period, as Tim Cook mentioned, and for this reason they moved in the ARM. ARM architecture is also the future. Repeat, is for the future for AI and for other things. We are talking about MPU, but even microcontroller are increasing. This is an example of MPU. This is the Raspberry, and it was last year that they presented Raspberry Model 4, 8 GB of RAM with a few dollars, let's say $50. It's really a low value of money, really low. It's an example of $2 MCU that you can use, and you can spread the world with many display, many stuff, and many of them. Now we are seeing them with 4G on board, GPS, Bluetooth, many capabilities, Wi-Fi, and blah, blah, blah. And recently was released even the RPI Pico from Raspberry that tried to enter and continue to be in evolution. Okay, we have all the ingredients together. Because we have all the ingredients together, we thought to introduce the osmosis process. So try to be away from an architecture, to be away from the cloud, the conventional cloud, to be away from the edge, from the fog, even from the continuum that try to make the piece, no, from these elements. So you make the piece before by the osmosis. Say, okay, don't care how you can exchange some elements. Look for the micro elements that can move, essentially, they can have this kind of a movement. And the example is conventional with chemical osmosis process, where you can have water on one side, sugar on the other side, and they can move internally thanks to the membrane. We defined also software-defined membrane in osmotic computing. You can have a cloud at the center edge, but you can have IoT, you can have fog. What you need, you don't care. What you need to find is quite tough as a job, is to find a simple rule to organize for the organization of this element. Okay, and repeat. We introduce the concept of membrane that you try to apply this concept to allow to allow these micro elements to move from the cloud to the fog, from the fog to the edge to IoT. And when they move, they have to leave something. They cannot bring everything. You cannot deploy all the services from the cloud to the edge. You have to reduce them. This is what you have to do in our idea. And this is how you can foresee graphically have a cycle on the cloud that became a triangle, but it became square or some other shape. Why different shape? Because you can have a different resource, a different capability. You have to reduce them in some way. But you can tune, as you can see in the slider at the top of the picture, you can tune. I want to put also in the picture AI, because AI is something that is affecting our life, because we are looking for autonomous cars, buses, ships. AI is there. We talk about AI every 20 seconds. If you see a meeting on television, use AI for bots, for video, for image, for speech. Alexa, we say, hello, Alexa, and say, what is the weather today in Messina? I can give an answer. Of course, in that case, as a professional in security, I'm a little bit scared because there is a mic connected with the Amazon headquarters in Seattle, in the good case. So this is what we are looking, human body comparison. So you have to know that every element in the body behaves thanks to the osmotic behavior. This is what is happening when you look for your neither, your breast, your brain, everything exchange oxygen and all the ingredients you need to live, essentially, by the osmotic behavior, the lung, everything. AI, human intelligence, is your brain. Instead, the osmotic is your body. This is what we have to put in place. And repeat, machine learning also, something on the top 2016, just to give you an overview is what's happening. What is a little good for AI, we know very well, we have the issue with the fake AI. I remember when I was in Philadelphia 2 years ago that IBM presented a real nightmare. They placed the post-it in the stop signal that the car was not stopped for a simple yellow post-it. It was really bad how to fake it because there was not any training set that time. For this reason, here in Messina, we're working on machine learning and reinforcement learning. And repeat, as I said, an example of human behavior and osmotic behavior is the HEARTH that allow you to live, essentially, with the electronic synchronization in this kind of example. There is no any control. This is what I'm saying. This is what I like to remark to you. By simple rule, the system is up and ready. Not complex, because otherwise you cannot control every element in your blood. It's crazy. You cannot do it. This is essentially the idea that we have several years ago with my colleague, Sharon Duster, Omer Rana, Rajiv Ranian, and Maria Fazio. It was during a proposal for a project, but it was quite new, challenging for understanding what we are doing. And we started with microservices. Okay, the small element is microservice, and then we move it towards the micro element in this perspective. We put in the picture already edge computing, security, networking. We have foresee what was the challenge at the time. Many of them was the idea to have this kind of orchestration and elasticity control of the system. In which scenario? In a federated scenario where you have everything in place, you don't care if you have IoT, edge, or cloud, they are federated with different policy, different administration domain, and you can use it easily. Okay, and repeat, this is give an idea how you can move from cloud to the fog or edge to IoT with different shapes. Cycles for cloud, triangles for micro element on the edge, and let's say squares for micro element on the IoT. Micro element. Here is the capability to now a monolithic approach. You continue to have, let's say, microservice approach, but in this case are micro elements because they are in some way composed by services and data, both together. This is what you are looking at. You can have on the cloud, you can have on the router, you can have on the Raspberry, you can have in the hospital, or the smart city, in any scenario. We are not starting from scratch. We are starting from existing there. So we're starting from Docker, and we look at how we can make a containerization, how we can make an abstraction, how we can make some description by YAML, even using Kubernetes, repeat, including the mail inside the pod, and leveraging what is there, even Accordion that we talk in a few minutes. And then also we try to deploy the idea of Osmotic in different languages, in JavaScript, in Lua, in MicroPython, on MSU, is a microcontroller. As I said, Lua, Python, and others. For having what? Microdata, MD, and to have a MS, microservices. And to have both of them for user purposes, but even for operating, let's say, because you need the real basis to making functionality and working to that. And repeat, Osmotic, you don't care. You consider a laptop, like in the picture, and on the left part of the picture, you can have a Raspberry, but you can have also Espruino, Arduino, like, and so on and so forth. It's important. Name service. This is what we are working these days. We have understood really complex to manage a lot of microservices, in this case, MERS, micro elements, that derived in microservices and microdata. As I said, are for user and for operational, and we try to have a different way to move. This is really important in Osmotic. There is no one direction. It's no cloud versus edge, and no vice versa. You don't make a priori an assumption. You can use as you like. This is essentially the idea. You see, micro elements, microservices for users and for operations, MS and MD for both cases. This is the idea to put in tag like you can do in containers to understand which version you have at which time and so on and so forth, just to have with the unique identifier to understand what is the current configuration of your environment. Something that you see already in containers. Something not really new. Okay, so name service, we are applying for software-defined membrane, SDM. Remember that we are trying to apply the the paradigm like you define things, software define anything. You can define an hybrid domain, you can define in federated domain, you can define what you want, essentially. This is why we're looking for having a set of definition for APIs, migrability of service, and movement of elements. This is why we introduced the concept of membrane. You see there, like a filter, no? Because you start from a cycle, and then by the membrane, the cycle becomes a triangle, because you don't bring with you all elements. Something already exists in the life, no particularly. You see the picture where you have this kind of colors in pink or orange, let's say much more in pink. Then the membrane. You try to create a membrane in between cloud, edge, and IoT, but you can create your membrane in your house with edge and IoT. And repeat, you have different type of membrane, because membranes can coexist. Software-defined membrane is an environment. It's an environment under the monitoring. You look to them, you try to understand what is happening inside the membrane easily. You see here one membrane, another membrane, bigger, small membrane, one in the house, one can be in the hospital, another one can be in the smart city. Repeat, the membrane you need, the membrane you control. If there is any issue in terms of security, you destroy the membrane. No any mail at all. You don't allow to move them. This is what we have done in terms of attacker security model. I remind every time the issue with a long time ago with LG monitor that they claimed it. They use it to open your cameras where they're in the living room, and even it was the small baby was woken up in the night by the baby monitoring system camera. So the idea is to have around this device a membrane that if something's happened, you destroy the membrane, you cannot access them. This is essentially the idea, easily in this domain. Namespace. Why do we need this namespace? Because it's a complex. I forgot to put in the slide a brilliant picture for Uber, where you cannot imagine how many microservices are deploying them for food, but it's becoming complex. This is why we strongly believe we need to see namespace from two different perspectives. One is just to see what we did in the past. Another one, what we have nowadays, and repeat, we are using osmotic computing in terms of core DNS. Let's look at the virtual level, at the machine level. I am making some investigation on Plan 9 from Bell Labs. It was really interesting to see something similar to Unix, but much more powerful, that I won't put you in your attention, essentially. Why this? Because they foresee any resource locally, but even remotely distributed, like a file, and you can mount them. There is a strongly concept mount without having some a priori protocols. It is really, really good. They have some namespace can be also mounted, and this kind of tree structure, and repeat, much more powerful respect to the Unix system, to the Linux, repeat, because you have this kind of object access protocol at the kernel level, at the kernel mode, and you don't need to identify which one you are using. It's transparent. You have some kind of API much more powerful. There is no any root domain. You can have a multi-tenant approach from, by definition, one resource belongs to Massimo, belongs to Patrizio, and they can use them without any risk. Something much more powerful with respect to the Unix. And repeat, everything after that you can use up to you. So funny, you can mount also virtual network, virtual NIC, and you can use them like different tunnels, different circuits, different pipes. Okay, but looking for the history, now we go toward the current situation. This is what Kubernetes is using, and even for Osmotic we are using today. It's a RESTful API that try to enrich the DNS capabilities. This is why we are using a lot core DNS as DNS resolver in our system. In this case, it was IMED for microservice, but we adapted for micro elements, not in hybrid clouds, but in clouds, edge, and IoT without any issue. Essentially, you can see in the picture that you continue to have DNS as it's working right now, because you are not putting the trash what you already have. But the idea is to have also different way to making some query on DNS to have some feedback with some data. This allows you to have the same service even in different cluster. This is what can happen with the core DNS. And repeat, you have also to understand how you can, let's say, mount the name of a different cluster, having the same exposition of UR, but then you can access underneath the original way where the original service is deployed. Sometimes it can be in cluster 1, sometimes it can be in cluster 2, but you don't care because you can move resource with one cluster to another cluster, of course, virtual resource, container, and microservices without having any issue in this perspective. And repeat, in this kind of new core DNS service, you can have errors, log, file, you can have, let's say, already proxy behavior, something that we know very well with NGIX, but you know, accessing with the file, and so on and so forth, example. Okay, this is an example where even here, guys, look, we are using etcd. Remember the key value that we thought about the lean NFV? Even here, we're using the same approach. Key value, you need some resources to make a query, and you achieve the resource. Again, repeat, we have the key value approach. And this is the idea with different colors, you can have a different mounting. Repeat, you can move easily services from one branch to another one, mounting the overall branch on top without any issue to reach down. This is an example mouse with the cluster local, but you can move the cluster locally with different private networks, and then you continue to satisfy to get the original data. Okay, what we did here for osmotic computing, we increased the concept of core DNS, having some kind of word domain DNS useful for osmotic computing, even introducing the third level with X, Y, and zeta with a 3 level in order to understand that point how it belongs to the world. Conventionally, you have computers with a useful DNS for users, and the idea also to put the full address is a address of our university, and so on and so forth. So look is something starting from Code Plus from Google, and we enriched it with the dimension. It was our idea to apply in osmotic computing. So we have worldwide DNS that allow you to understand what are your resources, but even transparent, because you believe to access some resources, some part of the world, instead they are totally transparent in another part of the world. You see, make a simple accessing of resource. You don't care. Osmotic, you should not care. Okay. Repeat, service is based on it works. You are there, you can use it. There is concept of service discovery in the area. So what is around me, proximity, is really important on the edge, and we have interoperability because it's relying core DNS, and you can have a migration of a service. Okay, it's based on plus code. You see here, even we put in place a core DNS, and this is the full name of plus code enriched what we've done with this kind of power 10. Depends how many characters to put. You have the precision of several meters, several centimeters, and several millimeters. Depends how long it is. If you reduce it, like when you make a phone call worldwide, you have the prefix, and then you put a number, put a number, put a number to have much more details into the location. As an example of osmotic migration that is working very well with this idea. And repeat, you don't care where the mails are, you can access them without any issue. Even there, we're going to conclude the final slides. We are managing also microservices and osmotic computing. We created, starting from Continuum, of course, Cloud Edge, but we want to be totally transparent. We overcome many issues that Kubernetes has, because Kubernetes is the king of Cloud Continuum in this case. And we have a prototype that we've done with thanks to my PhD student and master degree student in my university. They did a really great job. And repeat, just to have a possibility to run autonomy of nodes, interaction, peer-to-peer, in transparency. Okay, this is the first architecture, and we try to start and in mind something as a new concentration. Membran as a concentration the movement is allowed by the concentration. We apply osmosis in reality in this kind of idea. It's a distributed system, it's a peer-to-peer, and you have different nodes, and these nodes you can deploy microservice. In this case, we have microservices that can belong to one membrane, but can belong to another membrane. And we also create different membranes in this structure with different, as I said, concentration with different equilibrium try to maintain. Okay, this is an example of a network topology. They can be able now in this moment to move the data between data centers. We are making some experimentation with the University of Paris in these days, Sorbonne, also Reims, that to understand how the really distributed system can really work. What is a nightmare? It's a networking. Network is a nightmare, and we are using WebNet to have some kind of virtual network in order to guarantee the connection between two hosts, but even two hosts in between two different clusters worldwide. Okay, this is the structure of osmotic node structure. We have HG node, as we said, for guarantee the coordinates capability, but some other information useful for monitoring. And we have for networking, and we create a nano membrane. This is what we've done. In this case, we're using it for networking virtual networks. The key value store, we already mentioned it, and the monitoring. Repeat, it's not complex, but we are already making concrete some membranes. As you can see here, we have two different examples of membrane subspace where it's possible to give the chance microservice 1 to talk with microservice 0 to talk with microservice 3. All the membranes are separated and they have a different cluster, of course, as you can see by the IP networks, by the net mask. Repeat, HHD, we already mentioned it, we used it, and we are trying to manage the microservice by concentration. Okay, this is essentially the idea. We created osmotic membrane by YAML. We have defined it in our, let's say, prototype. And I show you several slides just to understand how membranes, equilibrium, and concentration works. Essentially the idea. You can consider three different microservices, MS0, MS1, they are not migratable. They can stay where they are, nodes 0 and node 1. MS2 is the jolly that allow you to move in one domain to another domain, in different membrane subspace. The membrane is one domain, okay? And membrane subspace is per node. You see the concentration is quite low. It is in CHAN. You can see different levels each other. Okay, what you have right now, with definition of microservice, they are pending, they are not running. If I have the capability in our system, operating in our system, where microservice 0 and 1 are deployed, and then can be in running mode, as you can see here in this picture. Okay, that we can ping because the network is working very well. They see each other. They don't have any issue. And this will be transparent. Essentially, for MS2, there is the only microservice is able to migrate. Essentially, idea. You increase the concentration, and concentration is funny because you can put in place one formula that allows you to understand what is the concentration. The concentration should be something related with the quality of service, should be with some kind of fault tolerance capability, even using CPU, RAM, and so on and so forth. But should be simple. One formula that deals with gas bed, concentration, and you change the behavior. This is what we thought in osmotic computing. Okay, for some reason, MS2 has some issue. We move it. We have seen before, was in membrane node 0, now it is in subspace node 1, and so on and so forth. If it is destroyed, we are able to recover it automatically by our system. It's up and running again by itself. And repeat, if the node disappears, concentration is changing, is the trigger, and you change and you deploy the service on the left part of the picture. The concentration, oh, excuse me, I don't know what's happened. Excuse me, we're going to conclude. As you can see here, the concentration is changing according to how much resource you are using. Repeat, everything is regulated by concentration. You can increase your membrane, you can decrease your membrane, everything should be automatically done. There is no human control. This is what you are looking. You have to guarantee equilibrium, you have to guarantee quality of service, you increase capability. You can do it, you go. If they can do it, you reduce. This is essential idea. You're going again to reduce. make some experimentation just to give you last 5 minutes to conclude. To understand, it's possible to use osmotic computing on the edge. It is possible. There's an experimentation on Raspberry that, as you can see, the cost on CPU, and then we see on the RAM, they are not massive. We're talking about 001, 0012 is quite low, at least for the first two, WebNet and TCT, key value things that it works. A bit more for manager and advisor that need some more resource. In terms of memory, repeat, we have seen good behavior with for memory that work very, very, very well, even if it's small device. Okay, now we go for a conclusion. Repeat, in the case of the work we are doing in prototype, we need to embrace microdata and memory discovery, and even to have a microservice public name system that means to apply the core DNS in reality in this perspective and to secure the nodes. So osmotic computing is something that we can file from IoT, edge, fog, cloud, can be osmotic, and even Continuum can benefit of it. Or you can say you start from osmotic, you can have any paradigm in the picture. We need to simplify. This is essentially what we're trying to put on the table, guys. We need to simplify to understand that we have something already in the nature, we should be by inspired. But the nature, because nobody is controlling each cells in our body. This is essentially the idea. And we have to understand that complex system in some way should have simple rules to have some kind of a bed, then you can apply AI, let's say, intelligence. So for the future, you can have, I don't know, I put on the table from smart to osmotic city, where people and device osmotically behave. I like these slides because if I link again with Gartner, going to conclusion, we go again towards the expectation, the peak of expectation in these days with AI of expectation, because 2020 and 2021 is the world API. I like Gartner, what they presented in the trend. You see there, we have internet for behaviors. So this is what's happening. You need AI engineering, you need a distributed cloud, is why it's good to go towards Cloud Continuum, but internet of behaviors. We see that people should osmotically behave. This is essentially an idea, our idea, and continue to be valid in this situation. Osmotic Lab, we started the collaboration with the website, Osmotic Computing Lab, with our colleagues. We make a website a few months ago because we want to collect some, let's say, community close together in this idea. Thank you for listening. If there is any question, let me say also thank you to, again, to Sharam, to Rajiv, to Maria, to Homer Rana.
Thank you very, very much, Massimo. So a big applause to you from us. Thank you for your presentation that has been very, very, very interesting. I appreciate a lot of the things that you presented us. Of course, I have a couple of questions, but before asking them, let me ask people, attendees, if they have any. I see one hand raised. Let me check. Who is Emanuele? Emanuele, you are allowed to talk now.
Hi, good afternoon, everybody. Can you hear me?
Very well, Emanuele.
Yes, thank you. Hi, this is Emanuele Carlini from CNR. Hi, Massimo. Hi, Patrizio.
Hi,
thank you very much, Massimo, for the interesting talk. I have a question that comes from one of the things you said earlier in the presentation, and basically here I repeat what you said, that big data is a driver.
Yeah.
And arguably one of the things that many people do nowadays with data is AI-based application, or let's say better, machine learning application, where they use the data to learn from experience, which is the data itself. So I was wondering two things. First, how the osmotic computing can help in order to set up, orchestrate, let's say, and do all the things that you mentioned in terms of this application. And also I would like to hear your opinion on the other side, this coin. So how the AI or machine learning can help the osmotic computing in deliver all the services that you presented today in the presentation. Thank you.
Thank you, Emanuele, for the great question, and you're totally right. Nowadays, we are really fully committed to the idea where we need data for this machine learning that is a change.
Massimo, we are losing you.
Put the post-it in yellow on the stop signal that the cars went through, because we have to understand that humans sometimes don't have a lot of data to train as to train on the field. It's the new trend of, let's say, reinforcement learning, or also this kind of swarm intelligence on the edge, because you see what you see, you try to learn. You don't have a lot of story of data. What does it mean this? I try to link with your question. You have to make things simple. You cannot have tons of data sometimes. You cannot learn from the data. And sometimes I can fake them, don't fit your scenario. This is what I'm saying, even for orchestration, for osmotic. I put on the picture the body and the head just to give you an idea where we are. We are in a situation where the body is there. So the body is controlled by the brain in our body, but in reality, many services, let's say, they're operating by themselves. So they don't need the full control. This is what we strongly believe. We have to have some kind that allow you to operate by itself, no full control. But of course, you need the brain, because the brain is able to give you the chance to talk, to raise your hand, and so on and so forth. We are Italians, no, Patrizio, and even more Sicilian. We use a lot of hands, by the way. I like to joke. And essentially, the osmotic, in my opinion, Emanuele, should give you the bed for making all the system assisting. And then you make the control by the AI, okay? This is what I'm saying. But even in the orchestration, you can have some reasoning stuff. You can have some elements that can learn by the environment where they are. But repeat, at the end of the day, you should have a layer that should be self-healing, should operate automatically, and then you operate by AI externally to change this behavior. But at the basis, it should work. I don't know, Emanuele, if I answered your question.
Yes, you answered. Basically, the AI can be from what I understood, are the can be those entities that turn the tune the system to in a way bend it to what you need. And the idea of osmotic computing is to provide the system to be tunable. Exactly. Yes, thank you.
You're welcome.
Okay, I see there is another hand raised. Luca, you are allowed to talk. Please go ahead.
Good morning to everybody. I'm Luca Ferruccio, member of the same team of Patrizio and Emanuele here at the CNR of Pisa. I have a questions that in some ways a bit similar to that of Emanuele, but it's on a little different topic. It is about the orchestration of osmotic computing. I saw during your presentation that there are some slides that are relative of a company which its name is Node Manager, which is about the orchestrating of osmotic elements. But what I understood about osmotics, that the granularity is very, very, very little, and that what you want to reach is in some way a balancing of load.
Me, I lost Luca. I lost a second. I don't know why. Let me verify what is happening. I lost a second of your. I'm changing the network because I'm with the mobile phone and.
Okay, it's not a problem.
I'm going to switch off the mobile phone. I'm going for fiber optics. Let me see, is it better or worse? Now it's off. Can you hear me?
Oh, yes.
Go ahead. Okay, go ahead. Excuse me. Last 10 seconds.
Yes.
Go ahead.
Okay. Can I restart?
Yeah.
Okay. I was asking about the scalability of orchestration techniques. I saw from your slides that you indicate some type of peer-to-peer network techniques. Yes, exactly, yes. And something like this. So you are imagining something this is a distributed orchestration technique,
exactly,
right?
Exactly,
okay.
Exactly.
What I'm asking for is that since the elements are very, very, very little, very granularity is very fine, and that very fine grained, and that they must move very, very, very reactively. Okay,
agree.
To the systems. How can you think to reach this reactiveness through peer-to-peer through some type of peer-to-peer techniques? Because it was not so clear. Or also other techniques similar to peer-to-peer, like gossip-based or DHT-based. I don't know.
Okay, Luca. Just to give you an example, the prototype we have seen in the slides is a new prototype, because what you want to achieve is we want to drive what you're saying by 2 main concepts: software-defined membrane, concentration, and equilibrium. This is what we are stressing, Luca. Okay.
Yes.
We want to be agnostic about the protocol you can use. It's up to you, don't worry. But what you want to achieve, let's look at the concentration, okay? The concentration should be a formula. This is what you are working in these days, Luca. Should be a formula that should come up what you are saying. And then when the concentration is changing, you immediately change the behavior. If you need something to react soon in a small round, you have a small membrane you have to monitor.
Okay.
You take the glue, so the membrane should.
So you reduce.
Exactly.
Let me know if I understand well. So you reduce the dimension of the cluster in some way to reduce time for orchestration.
Exactly.
Right.
And then because in your concentration, you put the time as the main, let's say, weighted value in your formula. This is what we are working at. At the end of the day, you look at concentration, you're okay. You are happy from some perspective. You can say, look, Massimo, but this is the membrane is small for that purpose. Yes, you're right. Inside that membrane, I guarantee what you are requiring there. If you need something more with less issue with the time, much more bigger, you have another membrane.
So yes, some type of hierarchy between membranes. Membrane.
There is no hierarchy. They are flat, but you can have many in the same nodes. Okay,
it's clear. Thank you very much.
You're welcome. But repeat, Luca, it is prototyping, is a start.
Yeah, I understand.
It's not something that give you any answer. I want to be clear that in our mind, we try to see things in a different way. That can the concentration really react to what you're saying? I cannot give you an answer, Luca, because we don't know really if with the concentration at the end of the day we can succeed. We are applying this concept, and then we see what's happened.
Okay, it's clear. Thank you very much.
Thank you, Luca.
Okay. So I don't see any further hand raised. I'll take the chance of asking the question I had in mind, if possible. Then in the meanwhile, if someone else want to ask questions, then just tell us. One thing that just out of curiosity that somehow links with the question that Luca just mentioned. I don't know, Massimo, if you had any chance to read the document that has been recently published by European Commission about the planning on the next digital decade. There is a plan of the Commission to getting back the sovereignty on the data. And in order to do this, instead of thinking on big installations such as cloud computing, the plan of the Commission is to instead go on the edge side. And more specifically, their plan is to have tens of thousands of edge nodes dispersed across the whole Europe. So given this perspective, I was wondering if you see the opportunity of setting up membranes and indexing of membranes as an interesting aspect to deal with, because if you consider the possibility of moving around in a place where institutionally it has been provided a lot of this installation, is make any sense to have an index possibly
a lot, Patrizio, a lot. We are totally aligned. There are some of my PhD students in the call right now. You can imagine how I'm stressing them. No cloud anymore. You are edge to cloud. This is now our rule. Edge to cloud, because we're working with the hospitals. You cannot imagine just to have some artifacts. And I stress a lot the concept of edge. The data are there. Don't worry. Data is in your house for your patient, is in your hospital, not any cloud in the middle, because you cannot do this. It's a funny, Patrizio, because I'm stressing them, then I realize they use WhatsApp. You know, you cannot possibly to use WhatsApp for, and we make also an application of that. We are totally aligned. Before to continue what I say, to be honest, I read the new format for making proposal. I have seen that they removed ambition, and they put interdisciplinarity, and we have something we have to think, and this is why we have to simplify stuff. And sometimes people said you need to have some osmosis among people, among doctors, practitioners, and so on and so forth. And I fully agree with you. The only way that you can guarantee privacy is maintaining the data there. And a membrane can be something that you can replicate, but you can also monitor. So you can say, okay, data should stay there. Membrane, it should be closed. I can monitor the membrane. If something's happened, I destroy the membrane. This is essentially the idea. So the membrane is because in the building, you have, I don't know, the COVID to monitoring. You create the membrane for the buildings, only to monitor. Out of the membrane come also some, let's say, anonymous data that give you 10 people with the COVID, 100, 1,000 in really big areas or so on. On the edge, you can manage by itself. You have the resource, stay there. If you need something, you move by the membrane. Membrane can give you the data, microdata. Why we put microdata in place? Because originally the idea was microservice. No, the future are microdata, because you have a lot of data, you change the shape, you move through the membrane, you have the reduced data. Anonymized data, we are happy. I fully agree with you. Patrizio, thank you for repeat. It was I'm looking also some feedback from the people, and first of all, thank you for the organization, because it's really great. I hope that the next time we can meet face to face.
Definitely, definitely.
Oh, today I realized that I don't know if make a good or bad to make the AstraZeneca vaccine. I did it, but sometimes you don't know it was good or not, according to what they're saying. Because you are under 60 years, and then let's see. By the way, but my hope is to meet all of you, even as some with some other projects. We have a Urbanite joint event. I repeat, Patrizia, I'm totally available, and it's always a pleasure.
Thank you very much, Massimo, and we really appreciate your availability, and it has been great. And then thank you again. Let me ask you my last question, please. Is I've seen that you did a lot of things regarding the analysis and experimentation of osmotic computing. I was wondering if you have any.
Patrizio, I lost your 10 seconds.
Sorry. Yes, Massimo.
I lost your 10 seconds. I did a lot of experimentation then.
Yeah, but I was wondering if you have any formalization of the approach.
Not yet. Not yet. Not yet. It's something that many people try to help me in this perspective, but we should. I fully agree that we should have some kind of formula. But it's a word, as you can imagine. You cannot have all the effort in dealing with this.
No, of course. But again, I think that not only as a CNR, that as you know, we are definitely interested, but maybe many partners here may be interested in collaborating with you on this.
We are totally available. We are already in the connection with people in Paris, Sorbonne, and some other people in Reims, but even with the people Sharon Duster in Vienna, Overrun, that we are working. I think we are going also to go towards a special issue on osmotic computing in a few weeks, and digital twins. That, you know, is something that we put on the table. It's not easy. I repeat, COVID is maintaining everything much more tough, but we try to do our best.
Okay, thank you. So I was wondering if there is any other further question. but I don't see any hand raised. So I guess that we can close here. And Massimo, thank you again a lot for your presentation. That has been really, really appreciated. Thank you.
Thank you, Patrizio, for the invitation and for all people that joined. Thank you a lot.
Thank you. Bye.
Bye-bye.
Bye-bye.